Limiting reagent calculations can always be tricky, but the best thing to remember is that bridge that we worked through earlier this semester. If we're going to use a balanced chemical equation, right, and we have grams, the first thing we need to do is find moles. So I have grams of something, I need to find moles. And to do that, I'm going to use the molecular weight or the atomic weight of what I'm working with. After that, I can convert to the moles of what I'm looking for using the ratio from the balanced equation. So this would be moles at the start, moles of the product, and I can also find the grams of the product using my new molecular weight, the molecular weight of the product I'm working with. We could also use atomic weight depending on what we're making. So that's the process we need to think about. If I have grams, the first thing I need to do is find moles. If I have moles, then I'm going to use the coefficients from the balanced equation to find moles of what I'm looking for. So we're given the following reaction, the Haber process. Nitrogen reacts with hydrogen to produce ammonia. How many grams of ammonia would be made if 12.2 grams of nitrogen is 28 grams per mole, and 4.12 grams of hydrogen, that's 2 grams per mole, are added to the reaction? Well, to determine our limiting reagent, we should probably calculate how much I could make for both of those. So I have grams, I need to find moles. So we're going to do the calculation for nitrogen. I have 12.2 grams of nitrogen, and I know that if I had 28 grams of nitrogen, I would have 1 mole of nitrogen. So grams of nitrogen cancel out, and that leaves you with 0.436 moles of nitrogen. So we've done the first step, grams to moles. We'll do the same process with hydrogen. So for hydrogen, I have a lot less. I have 4.12 grams of hydrogen, and I know that for 1 mole of hydrogen, I would need to have 2 grams of hydrogen. So dimensional analysis, right? Grams cancel out, and I have approximately 2.06 moles of hydrogen. Okay, great, we're done. We have a mole of each of those. We can figure out what the limiting reagent is. No, we do not. We need to convert both of these into moles of ammonia. We're looking for how many moles of ammonia we could make. So to that next step, we need to use the ratio from the balanced equation to relate those two. So I look at the reaction. For every 1 mole of nitrogen that goes in the reaction, 2 moles of ammonia go out. That is my conversion factor. That is my ratio. So for every 1 mole of N2 in, 2 moles of ammonia come out. And I want to do the same calculation for hydrogen, except for hydrogen, for every 3 moles of hydrogen in, 2 moles of ammonia come out. We need to make sure they're in the same units. Right now I've got moles of nitrogen, moles of hydrogen. Those are not the same units. Yes, they're both moles, but they're moles of different molecules, so I cannot compare them directly. So my dimensional analysis, moles of nitrogen cancel, moles of hydrogen cancel, and from the nitrogen, I could produce 0.872 moles of ammonia. From the hydrogen, I would produce approximately 1.37 moles of ammonia. Now I can compare those two values. Now those are in equal units. They're both in moles of ammonia. And now I can see that nitrogen is limiting this reaction. If I take a look, right, when all the nitrogen is gone, I would make 0.8 moles of ammonia. When all the hydrogen is gone, is consumed, I would make 1.37 moles of ammonia. So clearly the nitrogen is the limiting reagent, because that, when used completely, results in the smallest amount of product. That's limiting, right? That limits how much I can make in this reaction. But we're not done there, because the question asked for how many grams of ammonia we made. So I found out moles. I've got the last step. I need to go from moles of product to grams. So I have 0.872 moles of ammonia. Nitrogen is 14, hydrogen is 1 each. So for every 1 mole of ammonia, I would need 17 grams of ammonia. My dimensional analysis, moles of ammonia cancel out, and I would expect to make about 14.8 grams of ammonia in this reaction. If you weren't convinced, you could do the same calculation with this number here to see that it would result in a much larger mass of ammonia. So that's not possible, right? Because if I use all of the nitrogen in this reaction, I could only make 14.8 grams of ammonia, because nitrogen results in the fewest moles of ammonia. That is my limiting reagent. So the best thing to do in these calculations is to calculate how much product could I make given both of my starting materials. So do this full calculation all the way to moles for both starting materials so you can compare them on equal footing, right, with equal units for both of those. If you have a reaction where more than one product is formed, just pick one of the products and do the calculation for that product with both starting materials. We do not want to switch mid-calculation.